Today we're going to talk about slope-intercept form for a line. We're doing linear equations. Okay. First thing you need to know, the parent function is the simplest form of a function. And this is true for all types of functions, all types of equations. The parent one is the simplest one, the most basic version of it. And this happens with every type of equation that we have. A linear equation is an equation that models a linear situation, i.e. a straight line. The parent function is y equals x. Y equals x is the simplest, easiest, basic form of a linear equation. It's called the parent function because nothing is being done to it. It's just y equals x. There's no change in slope, there's no change in intercept, none of that stuff. There's no changes to it. It's the parent function is the basic one. Okay. The key thing about linear equations, variables will only be raised to a power of 1. There are no x squares, there are no square roots, or anything like that in a linear equation. You start adding exponents or radicals and stuff like that, it starts getting all curvy. No more straight lines. And then we have the y-intercept. The y-intercept of a graph is the y-coordinate of the point that crosses the crosses the y-axis, where it intercepts the y-axis. When something intercepts, they cross. The y-intercept is where it crosses the y-axis. The y-intercept is very important in linear equations. It's more important in linear equations than any other type of equation. Okay, the y-intercept is really, we use it a lot more in linear equations than anything else we do. Okay. So, formulas and properties. So, the most important formula you'll have today is slope-intercept form. Y equals mx plus b. M, we did M the other day. M stands for the slope of the line. B is what we use for the y-intercept. Okay. So M is our slope, and B is our y-intercept. Everything else stays the same. The y equals, and then some number times x, plus or minus some number. It's always that way. That's slope-intercept form. Y equals something x plus or minus something. Okay, that's what slope-intercept form is. An example is this one right here, and there's the graph for it. So we have y equals negative 2/3 x plus 4. This is our b, which is our y-intercept, is 4. That's where it crosses the y-axis. That's the idea behind it. The point that it crosses the y-axis, that's our y-intercept. That's the letter b. In that equation, it's 4, so it crosses the y-axis at 4. Our slope. Let's slide this up. Okay. That's our slope, negative 2/3. If I pick another point, and I go over and down, I go over 3 and down 2, our slope is our rise over run, so it'd be negative 2 over positive 3, our slope is 2/3. So you can see how the equation and the line, they match each other. Okay. Any questions so far? Well, not from you. Let's get down. Next page. Okay, so when you're graphing, and we're going to do a lot of graphing eventually, we're going to do a little bit here, but when you're looking at the equation, this is in slope-intercept form, mx plus b form. Identify the m, identify the b, identify the slope, identify the y-intercept. So on this first equation, what's our slope? 5, because it's the number times x. How many ever x's we have? That's our slope. So we have a slope of 5. What's our y-intercept? -2. Watch the negatives and positives. Okay. So if I were to graph it, I start at -2, and then I do a slope of 5. And for graphing purposes, always make it a fraction. When you're graphing, you need to make it a fraction so you can find your right and left for graphing. Okay. So the next one, what's our slope? -3. What's our y-intercept? 1. Now the last one. What's our slope? 1/4, because I have 1/4 x. What's our y-intercept? It's 0, because what do we have? We have plus what? When there's no number there that's being added on, it's the same thing as adding 0. There's nothing there, so our y-intercept is 0. Okay? Problem number 2, writing the equation in slope-intercept form. So, y equals mx plus b. Okay, I like to do this. Okay? The stuff in black never changes. The stuff in color is what changes. When we're writing the equation, we plug in those points. We plug in that part. So, I want to write the equation. I'm going to have y equals something x plus or minus something, and I got to figure out what those parts are. So, what is an equation line with a slope of -4/5? Well, slope is my m, and a y-intercept of 7. 7 is my b. B is y-intercept. Slope is m, b is y-intercept. So what do I do? Y equals -4/5 x plus 7. Piece of cake. Piece of cake. Given the slope and the intercept, what do? You plug the two numbers into the equation. Okay. Same idea. I need to find my y-intercept. I need to find my slope. But I have to do it instead from a graph. Well, the y-intercept, that's where it crosses the y-axis. So from my graph, my y-intercept is -2, because that's where the line crosses the y-axis, is at -2. Now I have to find my slope. So I do what we were doing the other day. Find a point somewhere along where the line crosses at the grid points and put in the triangle. As I go from one point to the other one, I go over 1 and then up 2. So our slope is rise over run, up 2 over 1. And what is 2 over 1? What is that? No, that's 1 over 2 is 1/2. It's 2. I have my slope, I have my y-intercept. Y equals mx plus b. I plug in my slope, 2. Plug in my b, -2. No, because the slope is going up. Because I went over and up, my line is going up. If your line goes up from left to right, you have a positive slope. If your line is going down, think about it this way. If this is a graph of the profits of my company, This would be a good thing, would it not? Because they're going up. So that's positive. If on the other hand, that was a graph of the profits of my company, that would be a bad thing. Makes it easy to remember that that's a negative slope. Okay, so when you look at the graph, it kind of helps a little bit with positive and negative.
If your money's going up, does that mean you have to hire more customers?
No, you don't hire customers.
I mean employees.
Depends.
People are
it depends. Okay, so he said the wrong word. Get over it. But no, it depends upon the company. I worked. Let me pause for a minute here. Okay. So this next part is the most difficult part of the day. Is the next one we're doing here. And what we need to do is we need to write the equation in slope-intercept form, but we don't have the slope, we don't have the intercept. So we have to find them. Now we did finding the slope the other day. Remember our equation, m equals y1 minus y2 over x1 minus x2. We do that to find the slope. We have to do that first. So our slope equals, pick a point, 1 minus negative 8 over 2 minus 5. Okay, 1 minus negative 8 is the same thing as 1 plus 8, which is 9. 2 minus 5 is negative 3. 9 divided by negative 3 is negative 3. So our slope is negative 3. Okay, so that part we did before. That part we know how to do. Finding your y-intercept is a little bit more difficult. Okay. There are several ways to do it. The way that I'm going to show you is the way that you best have the skills to do it now. Okay. So what you do is remember slope-intercept form, y equals mx plus b. I have my m, negative 3. I need to find my b. To find a b, this is what you do. You take mx plus b, plug in m, plug in one of the x and y coordinates. So I'm taking that equation, y equals mx plus b, plugging in negative 3 and picking one of these 2 points. Doesn't matter which one, I can pick either one of them. Now, for me, one of them seems easier than the other. The point 2, 1, because 1, both of the points are positive. I don't have to worry about negatives too much on that. And 2 and 1 are a lot easier to multiply than 5 and 8, right? So, mx plus b. So I have y equals mx plus b. I plug in a y, I'm using this point here, 1. Plug in my m, negative 3. Plug in my x, which is 2, to figure out my b. And you guys can do this. First thing I have to do, what's negative 3 times 2? Negative 6. So I'm going to have to move over here so I have room. 1 equals negative 6 plus b. How do I solve for b? I add 6 to both sides. 7 equals b. So I have my b, and I have my m. Now I can write my equation. Y equals negative 3x plus 7. And like I said, this is the most difficult thing today, is this. Okay. We will learn later on in this chapter other ways of writing equations that might actually be easier than this. Okay? And you're going to see this on a quiz coming up shortly. Okay, next part. Graphing a linear equation. It's actually really easy. First step, identify your slope and identify your y-intercept. So for the equation y equals 2x minus 1, what's my slope? What's my m? It's 2, not 2x, but just 2. Common mistake. And what's my y-intercept? What's my b? Negative 1. So here is how you graph. First part, put a point on the y-intercept. Negative 1 on the y-axis. Put a point there. From that point, okay, from there, make your slope a fraction and do your rise and run from your y-intercept. So rise as 2, run as 1. And here's what I like to do. I always like to do my run first and then my rise. So I go over, I always do my run in the positive direction. If my slope is positive, I go up for my rise. If my slope is negative, I go down for my rise. That's what I always do every time. I do my run, and up if it's positive slope, and down if it's negative slope. It's easy to remember up and down for negative and positive. There's my second point, and look what I have. Through those 2 points, there's my line. Y-intercept, slope from the y-intercept, rise and run. Got my line through my 2 points. And then last but not least, a plumber charges a $65 fee for repair plus $35 an hour. Write an equation to model the total cost of the repair, and that takes X hours. So it's going to be cost, which is Y, equals, and we'll put it in MX plus B form. So I have 2 parts to the equation. I have the constant amount that is the same every time, and then I have how much he charges per hour. Which one do you think would be the slope? The per hour one. So it would be 35x plus the $65 he charges. And then to graph, same thing we just did last time. What's my B? My B is 65. My slope is 35 over 1. So what I do, I go 65, which is somewhere about here. It's best I can do. And then 35 over 1. So I go over 1 and up 35 plus 65. That's 100. That makes that easy. And there's my graph. Okay. Over 1. Up 35. It doesn't really look like 1 and 35, does it? I think like 1 and 35 would be over tiny a little bit, not a whole lot, right? Scales are not the same, and it's okay that the scales aren't the same on the both axes. They don't have to be the same. Questions? A lot more information than we've gotten lately, but you guys can handle it. I have faith.